There are other ways of getting these coefficients of the terms of this binomial expansion. Let's take a look at permutation, which is given by something like this, which is also given by n factorial over n minus k factorial. And let's take a look at combination, which is given by nk over nk over k factorial, which is equal to n factorial over k factorial times n minus k factorial. Let's have some examples. Given the nth power of the binomial and 0k, n factorial over 0 factorial times n minus k factorial, which is equal to n factorial over k being 0 1. 0 factorial is equal to 1. This is equal to n factorial, which is equal to 1. And when the case is equal to 1, n factorial over 1 factorial times n minus 1 factorial, which is equal to n factorial over n minus 1 factorial, which is equal to n. And when k is equal to 2, it becomes n factorial over 2 factorial times n minus 2 factorial. And let's say k is equal to n minus 1 in this case, then combination becomes n factorial over n minus 1 factorial times n minus n minus, actually this becomes 1 because minus times plus minus times minus is equal to plus factorial, which is equal to n factorial over n minus 1 factorial times, this cancels out to 0, and this is equal to 1 factorial is equal to 1, so this becomes once again n. And when k is also equal to n, we have n factorial over n minus n factorial times n minus n factorial. This cancels out to 0, and n factorial over n factorial. 0 factorial becomes 1, so that's 1, so it becomes 1. So last time we said that this said this. Okay, now we are ready to continue. With this one, this becomes, once again, we still have the limit. And we expand this one to, we said when k equals 0, the coefficient is 1, and x n minus 0 is n, and k is 0. Anything to the 0th power is 1, so we leave it as that, plus, because it is summation, when k is equal to 0. Now k equals to 1, then the coefficient of the term becomes n, and n minus 1 times k is 1, so h, plus, and when k is equals to 2, the coefficient becomes n prime over 2 prime times n minus 2 prime x n minus 2 times h squared plus all the way when k is n minus 1, once again the coefficient becomes n. At this time k is n minus 1,
final 60 seconds,
so k x becomes n, or 1, h becomes x to the n minus 1 power, and when n is k equals to n, the coefficient becomes 1, and x to the nth minus nth power is equal to 0, and anything to the 0th power is 1, and h becomes nth power, and minus, and this
seconds,
x to the nth power all over h, as h approaches 0.
And time. Rest
And here
effort.
x to the nth power cancels out, and here we factor out h and cancel out h, we are gonna have something like limit of good factor of h n to the nth power plus n factorial 2 factorial times n minus 2 to 2h plus let's say I like to bring the h down here, and next term, which is this term, n times x times h to the nth minus 2 power plus h to the n plus minus, because minus 1 all over h as h approaches 0, and this h cancels out, and we have limit of nx. I will right here, oops, limit of n times minus 1 plus minus 2 factorial times n minus 2 factorial x to the nth minus 2h plus n times h is minus 2 plus h and minus 1. It's cancels out, so we don't have h anymore, and as h approaches 0, this h approaches 0, 0, 0. So only thing left here is n times x to the nth minus first power. Thus, we could conclude that the derivative of x to the nth power with respect to x is equal to n times x to the nth n minus 1 power.